So now I'm looking at ixl.p3, which is divide functions. This is a lot easier than the stuff that I put in class, which is fine. My guess is the first 9 or 10 are just things where kids will just randomly guess because that's what you do. You don't care if you know it or not. You just want to get your grade, right? Doesn't matter what you know. I don't know why after all these years you still think that's the easy way, but whatever. What is the domain of f over g? So the first thing I'm going to do is I'm actually going to write down f over g. F over g is negative 3x to the second over negative 2x plus 6. Now I've got it in math, the way I teach math, it's my second commandment in math. It says thou shalt not divide by 0. It's an abomination. You cannot divide by 0. That's the big deal. You cannot, that does not even look like the word cannot, divide by 0. So whatever your denominator is, cannot, will not ever be 0. Some teachers say equals 0. I like the inequalities here, not equal to 0. And then it's a two-step operation. Subtract 6, divide by negative 2, and you have a value of 3 as an answer. I'm just curious how many of these are like that. Oh, it says, what is the domain? I almost missed this myself. I said x couldn't be 3. It means I can be everything else but 3. All right, what is the domain of f of g again? 2x plus 2 over a negative 3x. And the deal here is that negative 3x cannot ever be 0. I've done this for so many years. There's a lot of kids who will say weird things here, and thankfully IXL didn't say something like negative 3 is an answer. But if you divide by a negative 3, then x obviously cannot be 0. So I'm everything but 0, all numbers except 0. Ta-da! All right, we got f over g again. Yeah, I can tell exactly what some kids will do on this one. Turnbow comes to mind. Turnbow just going to sit here and randomly guess until he gets on where he has to do some math. Yeah, I called you out. That's the function. The denominator can't be 0 because you cannot ever divide by 0. You got a two-step equation. 3x is not negative 1 when you do your subtraction operation. X is not negative 1 over 3. So all real numbers except negative 1/3. Fantastic. Nothing's really changed on this one. Wow, this is easy. But here we have a quadratic, so that actually is a little bit harder. Thank God you're in Algebra 2 and you know how to handle quadratics, right? The reason I wrote this out is because it's effortless and it's just less taxing to me for some reason. But the deal is don't divide by 0. That thing is not 0. First commandment of math, the way I teach it, is if you can pull it, pull it. I'm going to pull an x from both terms. Negative 2x minus 5 cannot be 0. Sorry, plus 5 cannot be 0. And then I'm going to use the cover-up technique. Well, I wish you could see this at home, but I'm going to use what's called the zero product property. One or both of these are 0. So x is not 0, or negative 2x plus 5 is not 0. One of the two. If I subtract my 5, 2x is not negative 5. Divide by my negative 2, x is not 5/2. So on this one, I had two things I couldn't be. I couldn't be 0, and I couldn't be 5/2. Honestly, the way they wrote this, you kind of cheat your way through it. This one's not even worth doing. Jump to level 5. Also not real. What do they want us to do? Write your answer as a polynomial. Oh, they want us to write the polynomial. They actually want to know what f of g is. Well, f of g is simply x over x plus 4. Goes right there. What can't I be? X plus 4 cannot be 0, so x cannot be negative 4. And that would go right there. That's how hard it is. Move up to level 6. Absolutely nothing special about this one. F over g is going to be 4x over a negative 4x plus 1. I'm going to type this in because I would be very curious if they allow me to have that negative symbol on the bottom. I got a hunch they don't care. I personally frown at the way I wrote that, but that's a me thing. And negative 4x plus 1 is not 0, so therefore x is not a quarter. Because if x was 1 and, oh man, I think all right. Because if x was a quarter, this thing wouldn't work. So let's see, I'm really curious whether it likes this, because if it doesn't, it's easy to fix. They don't care. Good for you. They don't care. Nothing here that bothers me. Go to level 7, see what level 7 looks like. Ugh. I like this one because this is a factoring problem. We have negative x over x squared plus 2x minus 3. That's going to go right there. That should be what's right there. I don't think they care about factoring. Now we have to figure out the domain. It's not where you can just push a choice and get it right. It's going to be two answers. But x squared plus 2x minus 3 cannot be 0. We factor using the guess and check technique or whatever technique you've been taught. Some of you watching this may not be my own students. Takes an x and an x to create x squared. Factors of 3 are going to be 1 and 3. To add to that positive 2 in the middle, the 3 is positive and the 1 is negative. And then I write my two equations using the zero product property. I guess in this case it's the not zero product property. This will tell me that x is not a 1, and this will tell me that x is not a negative 3. So just throw those bad boys right there, and you'll be done with it. Level 8. So boring. We've got a negative 2x plus a 5. Wish I would have thrown that away. Over negative 3x squared minus a 7x. We'll just throw that right there. Because apparently ixl doesn't care. Now we're going to take negative 3x squared minus 7x. We're going to say it's not 0 like I've done several times already. I'm actually going to pull a negative x. It doesn't really matter, but I'm going to pull a negative x. That'll leave me with 3x plus 7. You don't have to pull the negative symbol. Nothing wrong with not pulling the negative symbol. So if negative x is not 0, then I know that x is not 0. Put that one right there. If 3x plus 7 is not 0, then I know that 3x, don't let me do too much, 3x is not negative 7, and x is not negative 7/3. And that would go right there. And that is ixl.p3. Not something that's too terribly difficult. I don't think it is.